So now we're going to deal with the concept of an orthogonal projection of u onto v. So what this means is that if we have a vector v and a vector u, we drop a perpendicular, and then this right here, this blue vector, that is the projection of u onto, that is the projection of u onto v. And this is how we denote that. So, how do we find this? Well, we already know a couple of things. We know that this vector right here, its length, we know that this vector right here, we can write its length. We know if we have this angle theta, cosine of theta is going to be the length. We'll call this vector A for now. The length of A over the length of u. So the length of u times cosine of theta equals the length of A. So that tells me the length, and then this vector v tells me the direction. So we have u times cosine theta times v. That gives me my direction, but I need to divide by the length because I only want the direction, not the length, and that's going to give me my vector A. We also know that the length of u times cosine of theta, that is, we know that u dot v equals the length of v times the length of u times cosine of theta. So u dot v divided by the length of v equals the length of u times cosine of theta. So we're going to substitute that in. So we have u dot v over the length of v times vector v over the length of v equals our vector A. So the length of v times the length of v, well, that is u dot v over the length of v. So that is the square root of v1 squared plus v2 squared, etc., times square root of v1 squared plus v2 squared. So that is u dot v times the vector v, put parentheses around those, times v1 squared plus v2 squared. And v1 squared plus v2 squared is v dot v. So we have u dot v over v dot v times the vector v equals our projection of u onto v. The length of this vector, so the length of our projection. So we want to find the length of our projection. Well, we call that the scalar component of u in the direction of v, and the length of that, if this is vector u, this is angle theta, is cosine of theta times the length of u. And with some algebra, we can write this as u dot v over the length of v. So the scalar component of u onto v, so the length of, if we have vector u, vector v, drop our perpendicular. So the length of this vector is u dot v divided by the length of v. So the u dot v is 2 times 6 plus negative 1 times 3 plus 2 times negative 1 all over square root of 2 squared plus 3 squared plus negative 1 squared. So we get 12 minus 3 minus 2 all over square root of 4 plus 9 plus 1. So we have 7 over the square root of 14, and that is the length. So if we want to find the projection of u onto v, we can multiply the length, the scalar component, times the vector v divided by the length of v. So doing that, we know our scalar component is 7 over square root of 14. Our vector v is 2, 3, negative 1. We already found our length of v once. That was square root of 14. So we get 7 over 14 times 2, 3, negative 1, which is 1/2 times the vector 2, 1/2 times the vector 2, 3, negative 1. And that is our projection of u onto v. Find the orthogonal projection of u onto v if v is the vector 4, 5, 6 and u is the vector 1, 2, 3. So we know that the projection of u onto v is u dot v over v dot v times the vector v So first we need to find u dot v. So u dot v is 1 times 4 plus 2 times 5 plus 3 times 6, which gives us 32. Then we need to find v dot v, which is 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36. So we get 50, 60, 79.